hear us know the tune now?
Probably, just because it echoes through the hallway. Alright, so this is how we're going to be able to skip 624.
Quiet song.
So he takes a mildly different route.
There's a binomial formula with 2ax and b. So altogether this is the square of 2ax plus b, and now we have only 1x. So the next step would be to get rid of the square. And if the right side is not negative, the square root must be one solution. But there's an alternative because minus the square root means the same if you square it.
Plus or negative.
Plus minus, and now we are at the point where it only takes 2 more steps to solve it for x. And if you look to the left side, you know what will be next. Subtraction of b and division by 2a is giving us a formula for x. Okay, and it's negative.
So there we go. So there's your lesson 624.
That was just a quadratic formula.
Mm-hmm. So what we were going to do in 624, but I would rather keep moving forward to be able to have cool project time at the end of the year, like if we get done with all the teaching we need to do, is derive why the quadratic formula is what it is. But I think we've worked with it enough that you already believe it works because it does. And if we follow the algebra, we can actually derive that we have isolated x. That's what the quadratic formula is x isolated out of the quadratic expression for an equation. So what we're going to do with that is some application. I'd rather apply than just spend our time deriving that. So one thing we want to talk about really quick while we skip over 624 is when things are closed or open. Who can remind us of what it means when something is closed or open?
Closed or open under like addition or subtraction.
Give me more.
So like you can add like, let's say even numbers are closed under addition, because if you add two even numbers together, it's always even.
Okay. Are even numbers closed under division?
No. Can't nothing be really closed under division?
Nothing can be closed under division.
Because it makes it be.
That's a big
Never
assertion.
mind.
I'm not saying you're wrong. I'm just saying you said nothing.
Oh.
No, you don't know.
Everything's zero. Just divide it by zero.
Yeah, okay, so 0 kind of messes things up. So what about like rational and irrational numbers? So let's say that we're given this triangle here, right? It involves a couple rational lengths and an irrational length because radical 3 is not a rational value. So if we try to find the area or the perimeter, how would it work with rational and irrational numbers together? Can I multiply a rational number with an irrational number? Like, could I do an 1/8 times radical 3/8? Yeah, and then half of that. Can I add rational numbers to irrational numbers?
Well, you have to if you.
Simplify it.
Yeah.
You can add a rational number to an irrational.
So like if you're
Like
trying.
you can add pi to 3.
6.14.
So like if you're trying to add something to like the square root of 3, you'd have to like have a really long string of numbers to add it instead of just adding it. Well, like I don't know what I'm trying to say.
So.
What if they couldn't actually be like put together? Or what if we didn't want to write them together? Could I write like radical 3 plus 2 and talk about that as a value? Yeah. We did that with our quadratic, right? A lot of times we had a value outside of it, and then a value under the radical, and then a value in the denominator. Yeah. Okay. So are rational numbers closed under multiplication? Meaning if I multiply a rational by a rational, I get a rational. Yeah, we would venture to say, yeah, I mean, even 0 is a rational number, right? It can be written as a ratio. What about addition? A rational plus a rational.
A rational plus a rational would get a rational.
Yeah, like a fraction plus a fraction. Okay. Okay. Is there a way to answer D? Oh, that's the custodian's name.
Oh, I thought you were asking that
I thought
voice.
you were talking to
I thought you were asking that voice. Is there a way to answer you? I was like,
No, I was turning that down
is that
because it started making
mathematical?
noise as soon as I walked over. What do you guys think?
If you add any rational to any irrational number, will the sum always be rational? Or would it be irrational? So what's rational? I feel like if you add a rational number to an irrational number, it will still be irrational.
I
No,
feel
but
like it
no,
could be. I feel like sometimes it could be irrational, but
It could be
like
irrational.
mainly irrational.
No, because if you add it
Okay,
because
give
you
an
can
example.
change it to radical form and then add it.
So like a rational can become, or an irrational can become rational if it's like square root 3 times square root 3. Right? It becomes 3. What about square root 3 plus square root 3? Or radical 3 plus
Would
radical
get
3?
It
irrational.
would still be irrational.
It'd be
Still irrational.
If it's
What about radical 3 plus 2? Like plus a rational number.
It'd
It'd
still
still
be
be irrational.
irrational.
Still irrational.
So if you add it, then most likely it'll always be irrational.
Anytime we're using an irrational in addition, unlike multiplication, irrationals don't fix itself in addition. If it's an irrational number, it's an irrational number. And when you have an irrational number and, right, addition is and, you're still going to be irrational because now your group of values or whatever you want to call it, the and whatever you got a group now, we're irrational because we at least have. It's like when you have one crazy person in your group and you're trying to accomplish a task, and the crazy person keeps like impacting the group in a negative manner. And you're like, man, if only our group wasn't crazy. And you're like, hey, can you just stop being crazy? And they're like, yeah, sure, okay. And then they're like, your group is just crazy. You have an irrational number, right? I'm trying to relate irrational from like irrational when somebody calls somebody irrational is like, hey, you're being irrational.
That's
Like
a rational fear.
yeah, like if I was afraid of carpet,
What?
right? And like I'd say I couldn't be in this room because I'm afraid of carpet, and you'd be like, that's an irrational fear. Like it doesn't make sense, right? Why would you be afraid?
the whole scary part of monster.
I could make an argument for being afraid of carpet. It creates static electricity, and static electricity could cause explosions.
Yeah, but the chances of okay.
All right, so exactly what we were just talking about. Exactly what we were just talking about. Irrational numbers can fix themselves under multiplication, but the same does not happen under addition. Fundamental theorem of algebra.
For quadratic.
We know this because we've. Yes, I'm skipping through it very quickly. We know this from my wonderful little pamphlet about imaginary numbers being real. When we talked about the fundamental theorem of algebra, because anyone remember the mathematician? Starts with B. He's the bomb.
Bronx. Sorry.
Bombelli.
Bomb right.
Remember Raphael Bombelli, using the fundamental theorem of algebra, said, well, even quadratic formulas that don't appear to cross the x-axis have to have zeros, right? They have to have at least one. They exist. They may not be nice numbers, but they have to exist. So, moving into 625, let's apply this to an actual situation. Interesting.
What is that? Oh, probably Miss Pettigrew showing them some social things.
So go ahead and read this and start to chat with each other. I'm going to go ask Mrs. Pettigrew if we should start to be mean and hide Chromebooks that kids can't put away, because I'm about to start doing that with the 4 Chromebooks that apparently can't find their way to home. So start reading this situation and figure out how are we going to use quadratic knowledge and potentially the quadratic formula to maximize our area.
I just want to say, remember when Miss Pettigrew showed us that Greek song was like, I'm the daddy. Do y'all remember that? I'm the biggest daddy.
Oh, I remember that.
Yeah, it was so funny.
I think I was there because it sounds like something that would
This
would
is
remember.
gonna kill ya in a few days. The bubonic
No.
plague.
That's a different movie. Yeah.
What? No, friend.
No,
That was
this,
a lyric. Gonna kill ya in a few
I know
days.
that's the
I know, but
that, no, that's a bubonic plague song. I'm your dad. I'm the dad song.
I know, but I'm talking about a different song.
Oh,
I'm
okay.
talking about the Fleas on Rats song.
Oh yeah.
Fleas on Rats. Ooh, fleas on rats. Fleas on rats.
I'm just gonna do this.
I'm not
Like,
reading it.
we
They're just gonna
just like her daddy. Give her
Okay,
some
so
cows.
Can you make
Oh,
this
long as we want, and then you want the cows to have the most roaming space possible.
So the
Happy cows want a lot of space.
I don't think cows meow. Do they meow?
They moo,
Yeah,
they
and their
moo.
moo doesn't sound like moo.
No.
It's very long. It's like they're thinking about mooing before they moo. They're like,
It's like waking up and seeing a cow walking and just goes.
no joke. Where we go camp on my in-laws' property, right across the fence is a cow field. So if you've ever wondered, like, what's it like to wake up with like cows mooing? It's annoying.
I know. The feeling.
All right.
My grandpa
This
does have a big ranch.
maximizing this area is worth a piece of candy for all of you. Sorry, I can't do another ice cream sandwich, but we can wager a piece of candy because I want to try to not help you.
Okay. Wait, hold on. I did like some thinking.
So
Y'all got ice cream sandwich.
they have a wall.
And then you know we're not in
It's 30
Oh,
meters.
I'm bribing math counts today too. Math counts at extensions will have snacks. So
I
What?
want to go.
don't be greedy. We'll have snacks.
Wait, so it's against the wall.
If I go there just for the snacks, do a little
So
bit
we
of
have
math,
30
Wait, can you
is that
explain what we
okay?
doing?
Nope, you
here?
have to stay for math.
Wait, what we doing?
Well, what happens if I have to do my math?
You
we
solve
just
it.
like
And I just want
speed
snacks.
We just do math problems. Yeah. All right, not talking about math counts. So I challenge you guys to have the maximum area in 14 minutes
Okay, well, 30,
Okay.
30 meters.
because that puts us at 5 after.
30 meters on the perimeter, alright? What do we do?
Yeah, 30 minutes. Okay.
But then remember,
She
it's
will
only
use-
3 sides. It's for 3 sides because one is for
Yeah.
the wall.
Okay,
Because
so
in the wall we're assuming
I'm gonna
it's
draw
as long
a
as we want it to be.
diagram.
So
Yeah.
And it's rectangular.
Wait, does it say how many cows
no,
you
it
get?
doesn't say it has to be rectangular.
So
It says
the minimum is 30. You can do 30 by 1.
you used to build a rectangle.
Let me 29 because it.
No, it would have to be 50. No.
It'd be 28.
No, cause okay, so you can't. That's what.
Perimeter has.
Yeah, because it could be like 2. It could be like 1 on each.
No,
end
you
of
have
the
30.
block.
So you can basically have a perimeter of 30 plus the wall. Well, that wouldn't be helpful because it's 30 times, like 29 times a 1. Or no, 28 times 1.
No, it's
28
30 plus the wall. It's
Does it have to be a rectangle?
Hey, you guys can go draw up there if you want.
Wait, does it have
So-
to
You
be a
can make new
rectangle?
slides.
Strong
You can
family knows it's a rectangle.
No.
It's also a
hit the
square.
plus thing if you want a new slide. You know how to do new slide? Top, beside the arrow.
This one?
Yeah, a little page
So
plus.
can we-
I
Yep,
said,
there you
do
go.
we have to use a button?
Alright, draw
No.
a big line for the.
It could be a square.
Oh.
Oh.
Use a pencil or the pen thing.
Yeah, they're right here.
I'm double sluggish.
We have 2 equations, but neither of them are really helpful.
What?
So.
Everything is helpful.
30. That was.
What is that?
30.
I tried,
30.
but it was like.
It doesn't matter. Oh my goodness, Sammy. We
What?
are a time crunch.
Hit the pen. Hey, hit the pen.
We got
Hit the pen thing.
Look at that thing.
This thing?
Yeah, now hit calligraphy ink
What's that?
or pen
It's
or whatever.
for writing. It's
Yeah.
for writing.
Now change your size, it'll look fancy now.
Oh, look at
It'll adjust your letters exactly.
Do it.
So. 30.
Why?
Oh, wow.
Shirts. Cool. Me too.
That don't look like
So,
me.
okay.
Oh.
Okay, so we have this big line.
Oh,
So
shit.
we have a
To
wall.
make it like.
Wait, can I see this?
This is the mystery. I mean the mystery area. Hey!
Well, it's not really a mystery.
I'll.
Oh, my hard work.
The mystery I'm trying to say.
Christina, you wanna
Like it
No.
give
snaps
an
right
idea?
there, so this covers the entire
Okay.
screen. Why do you change it up?
Okay, you lost. Benny.
It doesn't matter. We don't have time. Sammy, we don't have time for this.
I like it better though.
Oh my.
I wasted like 30 seconds of our time. Okay.
Oh boy, 30
Be
seconds.
nice.
I just do.
Let us think.
What is your idea?
I just wanna give
These
you
3 sides have to add up. A, B, and C
Yeah.
have to equal 30, right?
No, but these don't have. Yeah, they do have to be the same.
You have 30
Yeah, they
meters
have
of
to be the
fencing.
same rules.
Because it's a rectangle. It's a rectangle. Like a weird.
Does it have to be a rectangle?
Yeah, it is.
Okay.
And then we're just trying to figure out what AB equals.
Trust me, you want it to be a rectangle. If I allow you to use any shape you want, this gets a lot more complicated.
Yeah.
He said so rectangle involving like squares.
Wait a minute, y'all.
Like,
What if it's
yeah,
somehow
maybe
just not
square,
one
but that's-
variable?
That would waste fence.
Triangle.
You try to make multiple shapes. One shape will be your maximizer.
Why?
Like, I don't know why, but it doesn't seem because like 28 times. Like.
What if we made this
compared
30
to, like,
minus
7 times
2b?
7.
Isn't it easier when there's only one
Wait.
variable?
Yes, that's true.
Yeah, don't work with two variables
Yeah,
if
that's
you
what.
don't have to.
30 minus 2b.
Yes. 30 minus
To
what?
be or not to be.
Something.
Okay, you might not want to stand in front of it because there's
And then we can
because I
solve
kind of want.
that.
By that, you might be trying to say, hey, could you please?
Okay.
You
That's a
mind
cow.
moving back
That's a
so
cow.
it's not a big crowd in
That's
front
a
of the
cow, you
screen?
guys. That's a
Solve
cow.
for me, Sophia.
What did you do?
Oh,
You write
Respect
multiple
your
outcomes.
time.
And I can
well,
draw them.
well, I went skateboarding and I
Oh, no.
fell and I kind of. So.
Okay, focus. I need to
How do we
focus.
solve this?
Plus 2b.
2b.
Well, isn't it just like
No, no.
30 plus?
90.
It must be 30.
Again, please stand back. So
Why are you over there?
Because
Why
only
did you
one
put that
person
B
can
there?
write on the board.
yeah, so you don't need to be crowding around the board. It's easier if you stand back and
Oh
one
yeah,
person can
never
write.
mind.
Yes.
Why did you? No.
That's okay. So that's our. How do we solve it? What does it equal?
Something's
Equals
equal to
a number.
30.
Mystery.
Why did you?
We don't have something on this side. That's our issue.
What did you do to do that?
Yeah.
She
I
just
did
okay.
that.
Because it's just this times that.
Okay.
The two side lengths multiplied. That's the area. Equals 30.
No. The
What is
area
it?
equals 30.
What?
No,
No,
the
the
perimeter.
perimeter.
Okay, the perimeter.
What do we do?
Wait, we're trying to use the least amount of the fencing to make the biggest area.
No,
That's not what I asked you
we
to do.
use all 30, but we need the biggest
If we
area.
knew,
Okay.
if we knew what the area
You want happy
was,
cows.
but like, we didn't know what.
You know what these cows can do?
I don't know how much
You're
they
training
care
to
if
be
it's
house
like
gas
a
emission.
Do you
foot.
eat meat?
No.
Oof. I think I eat more pork than beef.
Well, then consider it a pigsty.
Oh no.
You're trying to make happy pigs.
Oh, now they're big.
I don't think they really care if it was like a one.
They are.
Well, they
Greenhouse gas emissions.
care about how much space they have.
They like
There's no
more
space for you
space.
to like turn around. If they had 1 meter, they couldn't turn. They just be
Yeah, they
same
wouldn't like
position
that,
for the
but
rest
like
of their life.
I don't know.
we know that if we did it like a square, like 10, 10, and 10, that'd be like 100 square meters of space.
Yeah.
So then we'd probably want more than
100's a
that.
lot.
Wait, you guys.
That's if we did like a square.
Yeah.
So,
So
we know that.
So there's
30.
This isn't just a cow joke, but you're so close you can smell it.
I don't. Okay.
I don't
that
get it.
was
What does that do with cows?
30 minus.
well. If you do
Cow poop smells a lot.
Oh.
When you're
Yeah,
close to a
it's-
cow field, you can smell it.
if we do 7, 7, and 16, you get 112.
This equals the area,
Ooh, good job.
right? This.
Yeah.
Try like
So I'm gonna do.
So,
try 6 and the next one.
we want the biggest area.
Well, we have a number chart here, guys. If you forget how to count, it's over there.
It's funny because 7 and so 7, 7, and 16 is
What's
112.
after 6?
8,
The foil.
8, and 14
I
is
already did it.
112.
Oh, that's the foil version?
That's the yeah. That's.
Okay.
It's almost like your teacher would expect that you have some sort of skill set that would help you be efficient with this.
Yeah, me too.
Here. So.
Let's think for a second,
The
y'all.
question is, how do we do this efficient?
Okay, let's call the area C so we can see that.
So
Something like sort of similar to what we did yesterday.
It probably is. Cause it's like a.
Okay, so like.
Oh, maybe it's like the
Like-
straight. Yeah, maybe.
And then
that's what we're
flip it. Yeah.
I think the longer this thing is, the bigger it'll be. The longer the track.
yeah.
I agree with that.
Yeah.
So how can we find the longest?
Next.
The longest hypotenuse?
Yeah. Cause think
Blue,
about it.
blue.
How do we find it?
The hypotenuse?
Yeah.
Let's do this square, that square that we found this, right?
That doesn't. Like, we can't do anything.
30
It's
minus
more
2b
variables.
squared plus b squared equals hypotenuse squared. Root it. We got
Can
it.
I do something?
I
Okay.
think.
I don't know if this is helpful. So actually, you can keep doing that. I'll do that on paper to see if it's helpful.
Well, cool. I mean,
Why does maximizing the hypotenuse maximize your area?
Because the longer
When the hypotenuse increases, it means that the
and the area.
Not
it only means that
necessarily.
the leg is
Because if it's
increasing.
I bet you I could make a really long hypotenuse but a really narrow pen.
yeah, because if it's 1/28, then it would be a really long hypotenuse, but not the biggest pin.
We're looking for area.
Okay.
Yeah,
But
that
we
pen
have
would
a
have an area
limited
of 28.
perimeter.
Yeah.
The bigger.
As opposed to you
But
could just
we
do
can
like 10, 10,
change
10,
the
and that would have
length
an area
of
of
the
100.
perimeter to make
Guys, at a minimum, we know we can make an area of 100, right?
Yeah.
10, 10,
And we know
10.
15 and 7.5 is 112.5.
Which is one of the biggest.
Which is the
There's
biggest.
gotta be
So
some
this could
efficient
also be
way.
equal to B, y'all. So we actually don't know these lengths, right? Because we can't say this is 30 minus 2B because we don't actually know, we don't have to make a moment.
Well, you don't know it because you're
This is
determining
already.
it. The length doesn't exist yet. You're deciding what to make the length.
What?
I feel like they'd be
Should we just
happy
like
with
guess and check and make a bit like guess and
112
check one?
square meters.
No, but it's
The
gonna
cows
be decimal.
know.
Like there's infinite possibilities.
Every square meter, they know.
Well, we
I
need a
don't know.
base, right?
Their
So
moo
to
is
know
saying
which direction to go in,
meter.
right? It's better than what we're doing.
I know the difference.
Sandy skips
Or do we
meters.
want
Okay,
Yeah.
good job there.
No, I just did like I did.
Does anyone want the pen?
So, for me to ask some questions. What is 30b, is that times or minus?
Minus.
30b minus 2b
I
squared.
feel
What
like
is
there'd be
that?
some. I don't know. I always wondered.
That is the area.
that's
No, that's
The
that's
area?
No, this is the length.
No, I said what is 30b minus 2b squared?
I don't know, I was just doing.
Over in the middle of the screen, up
Yes.
here.
There.
If it's a perfect
This.
square, that would be
So
So that's area.
yes.
What if we got to
And area's changing, right?
There's two variables.
And one thing we said is if we went 1/28, give you a really long hypotenuse, but you don't have an area of 28. But 10 by 10 by 10, we have an area of 100. So area is not fixed,
yeah.
right? If you go from an area of 1, or a B of 1 to a B of 2, your area would actually become, take off 4, 26 times 4, 100, 104, right? 26 times 4? Yeah. Or no, it'd actually be 26 times 2. Sorry, not times 4, because 4 is both of them together. So we'd get like 40, 52. And so we go from an area of 28 to an area of 52. I go to a B of 3. I'm betting this isn't a linear change.
No, it'd probably be like exponential. Like we could probably
It's
make a
going
parabola.
around. I realize it.
Ooh, we
We
could
have
do
to
like.
take advantage of this wall. So we want to make this like be as long, like longer. So we get like, because if we make this really short, then like we only save one like yard.
So we use the entire wall.
Now remember, you're talking perimeter versus area. You want to maximize area. You're discussing perimeter right now.
What we could do is we could make it into like a type of parabola where we know like the ones that it was like 1 and 28 is the lowest it can be, and then we know that, and then you know how it
Wait
kind
a
of
minute, y'all.
you know how it kind of like reflects like 1 and 28 or 28 and 1, and then we can figure out the center, and then we know that's one of the what's it called, variables. So if we figure out 1, then it'd be easier to figure out.
Now remember, the points that we'll end up graphing are the B value that you have up there and the area, right?
Oh
the
my
Y will be
gosh.
the area.
Well, so we make a parabola.
What about 12 and 9
find
and
the
9? Okay, it's bigger than 10, 10, 10.
9 times.
Because 12 times.
So that'd be 108, but I did 8 and 14 and 7 and 16, and that was 112. But when I did 7
Wait, guys, you graph it.
and
I think I got it.
Oh, he got it.
oh, we're gonna should I graph it? I'll let you graph
We
it.
gonna graph it.
Alright, to step in and do a tiny bit, but then I promise I will step out again.
Are we on the right
So
side?
you said, I mean, you're in the right barnyard at least.
A barnyard.
Yeah.
Oh no.
More like cow.
So you said when B, we'll call it X. When X is 1, the area ends up to be 28.
Yes.
When X is 2, the area became like 50 something.
Oh, this is gonna be a parabola.
So you're hypothesizing it's going to look like this.
Yeah, and then at the top.
And
like,
what
would be the
we're looking for is this.
Yeah.
So do we change it to
So,
a
if
quadratic?
You do the math. We have to
So
find
if
the
you
math.
know these two, then you can do the difference in between. That's the highest, and then you'd want
X
figure
max A.
out.
Oh,
Because wouldn't this be? This would be one.
No, you guys are supposed to finish it.
This would be 1 and 28, and then this would be 28 and 1,
It's
right?
10 and
Okay,
100.
y'all stop it.
Wait.
Remember, you're graphing width versus area.
So
I agree with your
probably-
1 and 28, but be careful assuming that 28 and 1 is a point there. Because what you're saying is with a b of 28, your area is 1. The point 28 and 1 does not exist. Because that would be with a width of 28, an area of... So actually, you can't have an x of 28. Your maximum x would be 15, sorry, and then there'd be no pen, right? Because if x is 15, there'd be no... Wait.
No.
Yeah. If x is 15, if this was 15 out and 15 back, is there any space in the fence?
Nope.
Wait, you mean it has to go back?
I just think that's a 0.
15 out and then 15 back.
Look, there's another 15 here.
Oh, that's what he's talking about. Okay.
So, I'm confused about what you mean by 15 out and 15 back.
Okay, look, if we do 15 here and 15 here,
We
there's no space
talking
out
about
of
15 out, then 15 back like that with no.
You'd use all your fence, but you wouldn't have an area.
Oh,
Yeah.
snap. And the cows would
So
just
then
go
this one would be like, that'd be 15. So
Is there a way to mathematically
15 here.
check if that would be a 0?
Less than 15.
you could do
Put it into
15,
the equation.
15, and then
I'm going to sit back down.
wait.
You guys are over your time, by the way.
Oh.
You have 8 minutes before I walk you through it, and that's just depressing. So you should get there before I
Oh
get
my
you
gosh,
there.
we can do it, you guys.
15's a 0. I can prove that 2 times 30 minus 2 times 15 is 0.
Yeah.
I'm sorry.
It's fine. It's fine.
What would be your other 0? How could you reason through to that?
Because,
It would
like,
Other
what if
It'd
it's
be
too
28.
little?
It'd be
What,
28.
like,
It'd be like,
No.
well, no, it'd be
The other 0.
less than 20.
What's your x value
The
at
other
your other
0
0?
would be if it was just 30 along the wall.
Yeah, I guess.
What's that make your b or your x?
Negative 3. No. What would be?
If your fence runs just completely along the wall,
Yeah.
how far out from the wall is it?
0 feet.
0. So it'd be
0
0,
meters.
0.
snap.
Well, if it's technically along the wall, it'd have to be out some distance, but like.
Not if we're doing a mathematical system.
That's what I was
It
saying.
could be on top of the same, like, it's on top of the wall. It's
no,
in the wall. It's a fence wall
So this would be
section.
the coordinate 0, 0,
It'd
right?
be more likely the fence would be in the wall if the wall was made of trees. Because
Yeah,
trees
and
like
you
to
know
go
the
around
text
fences.
directly between
Like
us, so
that's
that'd
not
be.
what it is.
That'd be 7.
Oh.
And
Why
then
did you-
so you do that. So
That's all we need, right?
Yeah.
That's all we need, because now we can find the other 7.
Okay. Why did
It'd
you
be
put
15. It'd be 15.
That's just like
7.5 and
equal
15.
Why did you put 0 down?
That's the y
that's
intercept.
other.
It's an x
zero.
intercept.
Okay.
Why? It's the
Um,
other
so-
x intercept.
It's
Hey, if your dimensions are 7.5 and 15, do you notice anything interesting about the shape you just created?
It's 2 squares.
2 perfect squares.
So, I was right when 7.5 and 15 were the best because it was in between 2 112 and 112, so it'd be 112.5.
You had mirrors. You found your reflection. You found the peak of your parabola.
I could have been done 10 minutes ago.
Coulda.
Can
Shoulda,
we
woulda.
can we use the calculator?
Okay, it's 112.5. It's 7.5.
By the way, your veins are sweet. I just noticed that. All right, grab a seat. We'll get you out of here definitely early today.
No, we're going to the disgusting.
No, you got it.
Oh,
I was
This
a
is
big
probably why
fan
I'm
of
missing
my-
pens, because if they don't go up vertically, where'd the other one go?
Do you want me to?
I was thinking it was
Oh,
gonna be
no,
a
where
straight
did it
line
go?
like last time. So I
Were there
wasn't
2 over here?
no,
I
we
don't
ain't
know, I
got
just
one.
put one.
2? Oh, Liang has 1. Okay. No, we're good now. So, what's funny is I started the lesson showing you what you could have just used here. If we make finding this point and this point. Right now, I'm not saying factoring it would have been easy, but that quadratic formula that we talked about at the beginning of the lesson, really, our equation here is 2b squared. Sorry, negative 2b squared because the parabola flips upside down, plus 30b plus 0, right? Equals 0. So A, B, C, if we plug this into the quadratic, you quickly would have found that your 0 points are at 0 and 15. And this is actually 15, 0, by the way. Sorry, don't want to leave a point that's written wrong up there.
Yeah.
So once we have that, and actually, Sammy, why'd you get really frustrated?
Because I found it earlier.
What do you mean you found it?
Well, I found out that like 8 and 14 and then like 7 and 16 were both 112. So then I figured the midpoint would be the
So Sammy found.
But then everyone was over there and I tried to say something, but I forgot about it.
Power of guessing.
Sammy found 2 points that were sitting on the same Y line.
When guess and check got you.
Sammy, even if you had found 2 points, like let's say you did 5 and 10.
And then I could have done the midpoint of those.
Anytime we see the same output behavior, we know that we found one of those points of reflection, and we know that the midpoint of that will tell us where the vertex of this is. I know my arrows and stuff aren't quite all perfectly aligned how they should be, but does that make sense that as we play with one of these systems, like if we find an output here that matches an output there, what we've done is find 2 matching pieces of the parabola. Does that make sense a little bit?
I feel like normally the way you want to do it is find like 2 and then like.
Well, so here's the problem. We were all stuck in what we were trying to do. What if you flip the task on its head? Instead of finding the maximum area, what if we started by saying, what's the minimum area?
And then it'll be easier.
The minimum area is nothing. Right? The minimum area is nothing.
Does that mean just if you actually were trying to put the cows in a pen and just made nothing, then they roam freely and have all the space they want?
Or it depends how you visualize it, but they all dematerialize because there's no pen. But
Oh my god, what?
so if you imagine, like, here's your barnyard. I hate when it does that. Go away. Go away. Or sorry, here's your barn side wall thing, whatever. We said the minimum is when this is 15 and 15, right? Or when it's 0, making this run the entire 30. So that gives us this point and this point. From there, find the middle and find the y. That makes sense. Depends how you visualize it. If this one, the quadratic, wasn't completely necessary, but yeah, I mean, it could have helped us. If you try this in the quadratic, it'll work. Like, it will give you those points of 0 and 15. And that is our lesson.
Oh my.
That's disappointing. Why is it
We
disappointing?
didn't get the candy because we failed.
And we didn't
No,
get
we technically did it, but
Oh,
not
we
in
didn't
this
get
time.
it.
Yeah, you didn't do it in my timeline, and you didn't really do it without me. I had to kind of
Can we get pity
push you
candy?
along.
Can we get pity
No,
candy?
no, I'll give you another opportunity to get legitimate candy, but no pity candy. That would just, I'd be breaking my own policies then. I will say, be careful with this problem. It's one of those where, like, if you visualize it awkwardly, it's kind of awkward. So Maria's at her grandmother's house, which is located up on a hill. So imagine this is the road and the house is above the road level, right? It's a very difficult hill to climb as it is steep. There are stairs leading up to her grandmother's house. However, her grandmother needs a new ramp built so she can use her wheelchair to get to the front door. So Maria designs a ramp, creates the diagram as shown below. So imagine that this was kind of like the stairs, the land, the whatever that you used to climb up. Now we're making a less steep ramp for her to go up. So whether you visualize that as coming off the front door or coming away, yes, I just wanted to put that visual in your head of that is elevated compared to here. We're coming down a ramp. So if you want to visualize it, and this is why I pulled this up now.
Oh, it's so tricky.
there would be stairs, like down that diagonal line.
I feel like it would have made it better if they hadn't put it to a total point, but then it
Yeah.
would have been a triangle.
Right, like it's just hard to draw this in perspective. So yeah, that's that problem. So if we get messed up on that, we can go over that together. But in like 2 or 3 minutes, you guys can take off and head to lunch.